Howdy, here we are. We have pre-calc lesson 34, summation, notation, linear regression, and decomposing functions. This is completely new. You have not seen this before. Summation notation. What does it mean? We have what we call a sigma, okay? And your sigma will have a variable on the bottom, and it will have the least value of the variable. And up here, it will have the greatest value. And here, it will have some function, okay, that is happening on this variable. It is literally a sum of all the things happening, okay? If you can remember sum, you know summation notation. So I'm going to show you through an example. We are going to evaluate, we have this sum, I equals 1, 5, 3. So 1 is my least value, 5 is my greatest value, okay? Now, there's two ways you can think of this, okay? We have no variable term here. So you can think of it as the summation of I equals 1 of 3 times I to the 0, notating all the way up to 5. Now I to the 0 we know is 1, so this really is the same thing. And what we do is we start at 3, we plug in this value 1 for I, so we get 1 to the 0, plus 3 times 2 to the 0, plus 3 times 3 to the 0, plus 3 times 4 to the 0, plus 3 times 5 to the 0. I'm adding up each of these terms, which really gives me 3 plus 3 plus 3 plus 3 plus 3, which is 15. 15 is my answer. I is starting at 1. I'm plugging in the values for I, starting at 1, ending at 5. So 1, 2, 3, 4, 5. Now, another way you can think of this is if there's no variable, you're just summing 3, 1, 2, 3, 4, 5 times, because I start at 1 and I go to 5. All right, let's look at a little bit harder of an example. We have the summation of x equals 1 to 4 of 2x. So that means I have this function, 2 times x. I start at x equals 1, so I have 2 times 1. And I'm going to add to it, I go 2 times 2. Add to it 2 times 3. This 2 never changes. The only thing that's changing is my variable here, which I'm starting at 1 and I'm iterating up through my values until I get to 4. And then I simply add these together. 2 plus 4 plus 6 plus 8 gives me 20. That's my answer. Let's do a little bit of a harder one again. The summation from j equals 0 to 3 of 2 to the j over j plus 1. Now, j is our variable. We're iterating j from 0 to 3, so you have to plug in the values for both j's. So my first value, I have 2 to the 0 over 0 plus 1, plus 2 to the 1 over 1 plus 1, plus 2 to the 2 over 2 plus 1, plus 2 to the 3 over 3 plus 1. The only thing that's changing is my power here and this j value here, because that's where j is. I'm plugging in the value for j and I'm moving up and up and up. And this ends up giving me 16 over 3. The work that you show is exactly this. You show your start summation, then you show each of the different values and you get your final answer. Let's do another example. We have the summation from y equals 4 to 6 of 1 over y. So my least value is 4, so I have 1 over 4 plus 1 over 5. My greatest value is 6, so I have plus 1 over 6. And that's where I stop. I add these all together and it gives me 37 over 60. That's all. That's as high as I can go. All right. Now, let's talk about linear regression. Linear regression, it's graphs of experimental data that often indicates a linear relationship between two variables. Okay? It allows us to approximate things. Okay? So, we're going to use an example. As often, the best way to do math is just by example. Okay? If we're given this chart, carbon in grams and salt in grams, okay, we have 48, 0.8, 72.5, 95.4, 108, 7.8, 130, 6.3, 132, 9.4, and 158, 8.4. And it will ask us, write the equation of the line that gives salt as a function of carbon. Like so, S equals MC plus B. Okay? Now, what it's going to have you do is it's going to give you a graph. Okay, I'm going to draw it to the best of my abilities. You will not have to draw the graph. You do have to draw it in your notes. But you will be given the graph on your homework. Okay, and it looks like this. Okay, they are drawing the graph for you. What you are going to do is you're going to pick 2 points on this graph that your line goes through. Now, I'm going to tell you what the points are for the sake of making it easier in notes. Okay, so the points that I have are 160, 10, and 40, 0. So this is at 40. Okay, those are the 2 points that it gives me. Now, you are finding the 2 points on this graph. Okay, it will be the 2 points that this goes through, not these points that are circled, the 2 points that your line goes through. And we find our slope from this. I'm going to do 10 minus 0 over 160 minus 40, which gives me 10 over 120, which is about 0.083. Okay, so then I will have S is 0.083 C plus B. I'm going to plug in one of my points. I'm going to plug in the point 40, 0 to solve for B. And I get B is negative 3.32. So my final equation, S, is 0.083 C minus 3.32. Okay, it is literally going to give you the points on the graph. And you are just finding the equation of a line, like you've been doing since algebra half. Okay, nothing more than that. As always, if you have questions, bring it to class. That's all on linear regression for now. Let's go to decomposing functions. Okay, we were doing before composite functions, which is g of f of x. So that means g of f of x. I'm plugging in f of x into g. So if I said g of x was x squared plus 1 and f of x was the square root of x, then g of f of x, I plug in the square root of x for f into the x and g, giving me the square root of x squared plus 1, which is just x plus 1. Okay? What decomposing functions is we're given this and we're going to go backwards. Okay, so let me show you through an example. You're going to find 2 functions, f and g, such that f of g of x is the square root of x squared plus 1. So this means we're plugging in g of x into f. So I would take this whole inner part and say that is g of x. And I'm going to say f of x is the square root of x. So now f of g of x, right, this is my answer, but to check, I plug in g of x into f, so I get the square root of x squared plus 1. Ta-da! Okay, let's do another example. Find f where g of x is x squared plus 1 and f of g of x is 1 over x squared plus 1. So if g of x is x squared plus 1 and I've plugged in g of x into f, there's really no work to show. I just show that f of x is 1 over x. And we can check this because f of g of x, if f of x is 1 over x, I'm plugging in g of x into f, which means I get 1 over x squared plus 1. If you don't understand composite functions, you're going to have a much harder time with decomposing functions. So please make sure that you understand composite functions, and if you don't, come in and ask. But for now, that is all for lesson 34. We'll see you tomorrow.